For COS 225 at the University of Maine, which was object-oriented, Introduction to Object-Oriented Programming, we had a bonus problem of taking our infected turtles project and turning it into sheep or rabbits eating grass. It requires energy for the sheep to move, and when the energy reaches zero, they die. But if the sheep eat grass, their energy increases, and if it reaches a threshold, the sheep then spawn a child. So, like my infection spreading simulation, there are configuration options, such as starting population size. Because these are going to be sheep that are giving birth to other sheep, I started it small so they can the population can grow as grass gets eaten. Start energy is the amount of energy that the sheep start with when they're born. Grass energy is the amount of energy they gain from eating grass. Move energy is the amount of energy it takes for the sheep to move. Spawn energy is the threshold to spawn a child. And then there's the move speed and turn speed, like before. As you can see, as the population grows, food becomes more scarce because the grass is growing at a constant rate of randomly setting blocks to, grass to be in. So the graph down here, instead of showing a percentage like the infected rate, it's showing a population size. And so you can see that it peaked population at 371, but currently it's closer to 330 is what could be sustained, because it gets to a point where there's not enough food, for a sheep to survive, so it dies out, or the population remains steady. We could see what happens when we change some of these. I'm not actually sure. What is going to happen exactly. That should cause a slower growth in population. Now, I'm going to actually increase the speed also, and maybe decrease that. So now we should see, different population growth behaviors. Hopefully what will happen is there's going to be more grass in general in the terrain, because it's going to be no, maybe not. I was thinking because the population would be growing slower, but the sheep are still going to have to be eating a lot of it. But anyhow, you kind of see like the effects of changing the parameters down here. So it looks like the population size is going to level out lower than the default values. So basically, that's the basic idea of this bonus problem.